Right, we may run a little late. I have too much on my chest. So stay with me, please, okay? If you need to go, you can go, but please stay with me. The best slide is the last. I'm not kidding. All right. So this is about this, but I want to make clear that you have your rights. Okay? Europeans are good at regulation, and they regulated your rights as a conference attendee. You can ask, how does this stuff help my AI coding assistant? Every talk you go to, the first minute you can stand up and say, within my rights given by CRAP. That's the abbreviation. I can ask these 3 questions, okay? And because there's a lot of fake news and all that stuff, I put the reference down there. And the most significant bit here, although this talk is not about AI coding helpers, I'm telling you, please stop using chatbots. Stop using the goddamn chatbots. Stop using them. Use agents. Okay? To prove, there's this public PR I made on my employer's website, repository. And the way it works is a coworker wrote me a Slack message and they said, we found this bug in your code and it only manifests itself in GCC 14 on this particular Linux version. And it's only in one of our containers, and it's a very narrow thing, and GCC 14 is wrongly assuming you're using something uninitialized. It's not the case, but you gotta kind of finagle the code just a bit to make it work. And I wrote my coworker back, and I said, I'm on Windows 11 with WSL. I have a messed up Docker installation on Windows, and I have another distinct messed up installation on WSL. And I'm terrified, I level with you, I'm terrified of using Docker right now on this machine, right? And they said, well, you gotta kind of make it work. Then I said, fine, so I'm gonna run it straight without the machine, without the Docker, I'm gonna run it straight in the WSL machine, which has Ubuntu 22. And guess what? GCC 14 is not available on Ubuntu 22. So that didn't go well. So then guess what I did? I took my dialogue with my coworker, to whom I candidly told all of my problems in my life and marriage, and I put them in the prompt in Cursor. And I said, here's Cursor. Here's my situation right now. Analyze this, right? I know it's a mess, but, can you, and you know what? Cursor said, I'm gonna fix it for you. Let me run first what version of WSL you have. Like, it started me from the very beginning. It started me with my childhood, all right? Started from the very beginning. It said, what WSL do you have? Let's see your Docker, let's see this. It actually kind of figure out a lot of stuff about my machine that I didn't know about. The thing is, the assistant, the agent can actually run things on your machine with your approval. Our security team has, some settings. You can only run if you kind of click run for each command, which is boring, but a lot faster than typing it yourself, especially when you have no idea what to type. Right? So then you figure out the Docker. It started the Docker. It debugged my stuff inside the Docker. It ran GDB inside the Docker several times. And then he said, I found your problem. Want me to fix it? And I said, yes, please. Right? He said, sure. So he changed a couple of files. And without understanding the bug, and without understanding what the hell I was doing, I had the bug report with emojis in the GitHub message. And only on this last point, I mean, how can anybody compete with somebody with a machine that generates nicely formatted GitHub PR messages with emojis in them? right? So the motivation for this talk in particular has nothing to do with AI, although it does. Because every so often I'm going to sprinkle a bit of information on how you can use this with an agent, right? It turns out that tuples, packs, and all that nonsense are instrumental to a bunch of scientific code. Tuples are used to model tensors, which are the basis of a lot of scientific codes, including, of course, AI. And to do so, you need inevitably to deal with parameter packs. Now, parameter packs is kind of a distinct thing with a prior status. You can't copy a parameter pack. You can't define one. You can't do a lot of things with them, right? And it's kind of a mess. So historically, you can say, I have a pack. Well, give me the second element of it. That's difficult. That's difficult, grasshopper, right? And then, people kind of started to using packs for a variety of things. And there came std integer sequence. You got to imagine, like, what kind of mess in the programming design, languages design space do you have to be such that integer sequence sounds like a good idea? Where should you be? In what dire situation in your life do you have to be? I remember when I learned about them. It was 2014, and this conference was back in Bellevue, Washington. Great digs, right? Too small. So I was there, Stefan T. Lavave, you know him, right? The STL. He was explaining me in the hallway how std integer sequence works. And I remember distinctly. He was explaining to me, and my mind started to work with febrility about the consequences and the implications and the future that I was facing. And I remember thinking at that very moment, I thought, if I run 10 meters through that window and fall to my death, I'm going to have a future in which a short future, albeit, in which I don't need to write any one line of code with integer sequence. But then reality kicked in. We're on the, floor 1. And that window, double pane, it can't, everything I would have gotten was at the best a concussion and still a bad memory of std integer sequence. So that didn't pan out. So then here we are, fast forward, and here we are, like in a Tarantino movie, right? So not too good. It has all the disadvantages of packs plus a few more. By the way, did you know that you can't implement std integer sequence in native C++? Except you can, but it's gonna be pig slow. Thank you. It's gonna be pig slow. All implementations are like, yeah, we know, it's a great idea, but it's too slow. So you're gonna make it a primitive, an intrinsic, or whatever, right? However, it's not all bad news. I'm happy I didn't jump through that window because template 4 is coming to cplusplus26 near you, right? And if you want to manipulate a pack, you can do it very nicely by means of, I'm going to use a template 4 right now, and I'm going to iterate a pack, or I can make an array, I can iterate a tuple, I can iterate a variety of things that are difficult to iterate. Better yet, that iteration is a pseudo iteration because in fact what you're doing, what the compiler does is going to paste the code several times for you, as opposed to generating code that iterates at runtime. That's nice. There's one more element of the future which has an awkward name. Structured bindings can introduce a pack. It made it in C++26, and it took 10 iterations. So it's R10 that made it the standard. In all of these 10 iterations, nobody saw they have the wrong capitalization here. But be that as it may be, it's a really nice feature. Thank you, Barry Revzin. You can actually bind a local pseudo variable to a tuple, for example. And you kind of unpack the tuple that way, and then you can use one of those fancy dot, dot, dot constructs that come straight from Venus, right? And you can inline things. So I'm not going to present to you a competition for dedicated libraries for metaprogramming, but what we're looking for here is some collection of very simple, I'm talking 10 lines. I'm talking like the whole talk, 50 lines, that you can take and use in your code and be very happy using them. Better yet, your agent is going to love them, because agents are very bad at creating new idioms. They're very good at using them. It's a fact of life. I'm not sure why, but that's how agents work. An agent will never generate the code that I'm going to show you here, but once you show it to them, say, yeah, that makes sense. Good job, little Andrei. Yeah, you did it. I'm going to use it. And you can actually explicitly tell it, use this idiom to implement that stuff, right? So that's pretty nice. So let's start with some basics, which I'm sure many of us have been going through. First of all, we want to define a function that does some iteration over a pack or a tuple. And as I'm sure you know, the first thing that any agent will do, including a human agent sometimes, print tuple implementation, right? And then you have print tuple, right? There's it's always two functions, right? The postman always rings twice, right? So you have this, first of all, I have this namespace detail, which will just once make me want to kill myself. But that's fine. And then you say, I'm going to pass one of those index sequences, and from the main function, I'm going to pass the index sequence into the second, and that's how the cookie crumbles, right? So this would be what every agent is going to recommend for it. I want to unpack a tuple, I want to mess with each element of it, and then it says, it takes you it's a highly optimized path in the neural brain of the model. It's going to output this code. Actually, this is copy pasta from that very thing, right? Fine, but there is a simple way that I wanted to show, which uses a lambda in C++20. I heard the chuckle somewhere, but this is not chuckle-worthy, my friends. This is serious stuff. So you define a lambda with an explicit size t ice, and it takes an index sequence. And the deal is, you're going to call it yourself. It's like an idiot. Remember back in the day, you had to write yourself a check if you wanted to take any cash from the bank. Okay, nobody's laughing because everybody's like, I wasn't born there then, so why do I care, right? It was the case, I'm not kidding. At Citibank, you would go into the bank, in the bank. There's a thing, you go in the bank, right? And you write yourself a check like an idiot, and then you give it to the cashier, and the cashier says, okay, so I'll give you the cash. And all of the transactions took only like 30 minutes, right? Plus the drive and whatever, right? So similarly, you call your own lambda like an idiot with the appropriate index sequence, and that's how the cookie crumbles once again, right? Fine. There is one other trick that I would love to give credit for. There's a simpler trick that works in C++17. If nobody claims the credit in 3, 2, 1, okay, I claim credit for it. There's the following trick you can use, but by the way, this is not the gist of the talk, so it's just a little thing. I don't care about this, right? So don't pay attention. On your phones. The trick you can use is, okay, I'm going to say template of type name tuple and the size t dot whatever, and you take it defaulted as the last parameter. Defaulted. What do you think ice is, if you call the function without that default argument, what do you think the ice dot are going to be, please? Anybody? Yes, please?
No.
Thank you very much, the empty set. It's going to create an integer sequence that is the empty set. It's the empty integer sequence, it has nothing in it, and the size of that thing is going to be 0, right? Fine. So I'm getting the default parameter, and I'm inside the function, and here I make a test, a very wily test, which is, well, are you the right size or not? If you're not the right size, then I'm going to call myself again, writing the check to myself, with the right size?
Why not check for 0?
Why not check for 0? Because I'm very happy you asked. Thank you very much, and good to meet you again. Why do so this half of the room? Why do you think I'm not checking against 0?
Empty tuple.
Huh?
Empty tuple.
No, because safety, friends. Yes, please.
There could be 0 elements in the tuple.
There could be zero elements in the tuple. Very nice. Thank you very much. Actually, I didn't think of that, so that's kind of an awkward moment. But I have another reason, which is, what if some safety, friends, security of software? What if some user decides to call this function with the wrong index sequence, with the wrong size? I have a tuple of size 5. They call it with index sequence of size 4. And then my check, if I check against 0, would pass without needing to pass. It shouldn't pass, right? So therefore, very clear, I say, are you the right size? And if you're not exactly the right size, no more nor less, I'm going to pseudo recurse to myself. That's not recursion, is it? We don't need to explain this. This is not recursion. You don't do like the stack frame, all that nonsense. No, you call a different function because that instantiation is going to be completely different, except in the case when the tuple is 0 size. Thank you very much. In that case, actually, it is recursion, which is kind of funny. Are you going to end with an endless loop? All right, so I got to confess something. So, I'm sure some of you have given public talks. When you're giving a public talk, you are in a state of severe cognitive impairment. Right? You can't think on your feet. If you told me what's 42 times 7, I can't tell you. All right? Nor can you, apparently. There's a dead silence. Do you see how awkward this moment is right now? So essentially, I can't think on my feet. So please, somebody, by the end of my talk, tell me whether this code is going to be liable to loop forever or not. Thank you. So our disposition following these discoveries is that, fine, we don't like the verbose version. The workarounds are still bulky. We want to stay as far from std integer sequence as possible, and that's going to save us nerves. It's going to save us mental health. It's going to keep the doctor, the shrink, poor. Okay? And then we're going to build some other primitives that are simple, nice, and beautiful. So let's write a function that unrolls some code several times. I say unroll of 5, you unroll the same code 5 times. That's all I want. And the first thought that comes to mind is, wait a second, there is a thing such as an unroll pragma in many compilers, right? You've heard of it? Heard of it? Unroll, pragma unroll. All right, so few people do parallel programming, friends. So few people. All right, it exists. No fake news here. So then I'm going to say pragma unroll, and it's going to unroll it for me, case closed. Or is it? No, because if I want to actually pass that loop variable as, I want to get the ith element of a tuple, it's not going to work because it's a runtime integer, not a compile time integer. What I want for true unrolling is I want you to call my lambda with 0, 1, 2, 3, etc. And I want to use inside the lambda that 0, 1, 2, 3, etc. as a compile time constant. Because the next thing I want to do is std get of 0, give me the 0th element from that tuple. And std get 1 and give me the first, and so on and so forth. Thank you for the nods. Yes?
MP with index.
Sorry?
MP with index.
With index.
MP11, MP with index.
MP with index.
Yes.
I don't know what that is.
Look it up after. It's
Thank you very much. Even though, there's a thing. In every talk, there's some guy who knows more than you. And you're that guy. Thank you very much. Let's do the second take, which is going to go something like this. I'm going to use my trick, whatever, unroll, and then I'm going to say f of I, comma, dot, 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 and I'm going to unroll f very beautifully. There is something still wrong with this. It's still bad, because if I want to say unroll 2 and I want to use a tuple with I here, I is still an integer, therefore a runtime variable, and therefore not suitable for compile time evaluation. Although everybody in this equation knows I is going to be 0 and 1, right? I know, the compiler knows. the optimizer knows. Everybody knows, except the kind of the rules of the language, if you wish, right? So they're going to be like, well, you're using a runtime variable here. No bueno, right? What's the solution to this? Yes, please.
Integer constant.
Thank you very much. Integral constant. I wasn't mistaken, was I?
No, yeah, right.
Oh, okay. All right, that's even the second shame. So the first shame I got there. Okay, so I have this integral constant trick, and I say, actually, if I create an integral constant here, and I iterate it through all of the i's, then very interestingly, the lambda is going to get here. Careful, it's got to be auto. If it's not auto, if it's size t, you lose information. You converted the compile time thing into a runtime thing. You don't want that, right? So what you want is, okay, so I'm going to take an auto, which is going to be integral constant of whatever 0, integral constant of whatever 1, and so on and so forth. And inside the function, very interestingly, you have an integral constant which converts automatically to integer. And the conversion operator is constexpr. So you can use it during compilation, or you can use it as a regular integer dynamically. So you have the best of all worlds, right? Not my idea. Not my idea. Exactly 35 people had this idea at the same exact time. All right, it's a quantum superposition kind of thing, right? 35 people. But the point is, too few, because the models didn't get it yet. So please use it more and publish your code on GitHub so the LLMs can pick it up, right? Fine. And all of a sudden, we have a very nice unroll primitive, and we're like, oh, I can use unrolling instead of all the nonsense with integer sequence. I can just pass a lambda. The lambda takes an auto. I get the index, and everybody's happy. Except sometimes there's a problem with TMI. Too much iteration, right? Too much iteration. Consider I want to find something in an array, and I iterate, and if I found the element, then what I want is to kind of stop the search and go home, right? Be done with it. So how can we change things so I actually get the benefit of an early termination? One convention I could go with is, how about the lambda returns, instead of returning void, it returns bool. And if it says true, then I continue iterating. And if it says false, then I'm done with iterating and I'm not evaluating anymore, right? All I need to change for those of you with very sharp eyes is going to be this one little double ampersand, right? Short circuit, friends, right? So you use this dot expansion, except instead of comma as we had before, if you go before. So if you go before, we had the comma here, right? And sorry, here. Where am I? Here. Instead of the comma, I'm going to have an ampersand, a double ampersand, which means I'm going to evaluate until the first one is false, and by the immutable loss of logic, I'm going to stop iterating, right? Fine. Which one do you like more? By means of applause. Do you like the first more with void? Yeah, thank you very much. Yeah, it's nice. Who likes the second most? A bit more, you see? You see? But, ¿por qué no los dos? Why don't we like both? Why don't we like both? Instead of writing two functions like an idiot, why don't we write one function and use a little introspection, my friends, for my life? Right? A little introspection there that is going to take me to where I want to be. Because inside my function, I can say, is the lambda returning void? Then I know what to do. It wants to iterate everything. Does it return bool? Then I know what to do. Something else. Right? How about the apples? So I go with, here I'm going to say, are you void? Is void v? By the way, is void v is a fancy way of saying, no, that's not loud. What is void v? Is, say, type v, whatever, comma, void, right? Why does it exist? For this slide. Thank you very much. So it makes the slide smaller. Perfect. That's actually pitch perfect. So then I say, oh, okay, so if const expert, very careful, right? If const expert, is it void? Then I'm going to use the comma, and otherwise I'm going to use the double ampersand. And you'll have to forgive me for the slight repetition of code. There is a bit of repetition, right? But not too much because it's a library function, and then we can use it a million times, right? So not too bad. So that's a micro idea. Again, no model I couldn't convince a model to build this, right? But once it sees it, it's like, I know what you did there, right? It's a bit frustrating, to be honest, right? So far we went through the following progression. So we have our roll of n with lambda, fine. We use the integer sequence streak, We pass the integral constant to the lambda, wow. And now we have the optional Hermit termination, and we are in absolute awe, right? Fine. Let's also create some stuff. So we know how to unroll things and to, expand lambdas, but let's also create a few of these tuples, compile time arrays, collections of things from packs. And let me introduce to you a filtering make tuple. A filtering make tuple. Filtering packs is very difficult because you can't return a pack. You see what I'm saying? You can take a pack, but you cannot give a pack. So you can't say, I'm going to take a pack, filter it, and then give you a pack back. You can't do that. Why? Actually, I don't know the answer, because this is the way, right? This is the language. It's the way it is, right? You cannot return a pack. So that's why packs are pariahs of the C++ language. But, I have this little idea. How about we create a special empty struct, which is called null field. It's a type that refuses to be part of a tuple. Interesting. So let's create a make tuple that while it's making things, it's also going to filter its stuff. And it filters it in such a way that whenever it finds a null tuple inside, it's going to not put it in the tuple. It's going to filter the tuple. Okay, so why do I have maybe unused this, do you think? Maybe unused. Because there's a bug in the compiler. I'll tell you exactly why. There's a bug in the compiler. It shouldn't be there because it's used. It's used because I'm taking the type of X. So anywho, I'm creating a little lambda here just to be fancy, and I'm going to say, are you convertible to const null field reference? There is a particular pattern here that is very important that you know about, which is whenever you want to say, are you of this type, but it could be const R value reference, L value reference without reference, it could be an R value, whatever. So any variations of these things all convert to const T reference. So whenever you want to say, are you some variation of this guy, you just say const guy ampersand. And that's going to catch everybody. Yes, don't tell me volatile, please. Okay, what you're about to say?
I'm not using stddk because it doesn't fit as right.
I'm not using stddk because, fluoride is not good for you. There's so many jokes in that. All right. So now I'm going to say, fine. So I have a filtering make tuple, which automatically is going to remove anything that is a null field. And just as an aside for everybody, I think there's a thing here. This null whatever, null tuple field, it's kind of a weird thing on first look. But any of you who has used C++ in anger for a while is going to be, wait a second. There's a general pattern here. The button type. The unit. Anybody who's coming from other languages is going to be, wait a second, I have unit in Haskell. Why don't I have unit in C++, right? So there's a thing which is called the null object pattern. And that null object pattern means there is one value that is singular in this realm of types, or there's a type that is singular among types and has special properties. It specifically has negative properties. Null is not a pointer. Null PTRT is a singular type that has essentially points to no object. You see? And once you start looking for these, you find them all over the place. Monostate. You know monostate? It exists. Monostate, it's a type that is like, I'm a type that does nothing. I'm guaranteed to have no state. It defines itself by means of a negative, right? We have ignore, the absence of mutation. We have null opt t, we have std ranges dangling, etc., etc. So in this panoply of great artifacts, why can't we have a null field as well? I am not the field of a tuple, right? Awesome, so that's an interesting thing. And by the way, I just found out literally today, I found out today that there are talks about adding a button type to C++. What is a button type? What? No, it's not void.
Void type.
Void type. No. Button, yes.
Can be substituted for any of those?
Yes. Button type is a type that converts to anything. Is the subclass of all classes, the subtype of all types, the ultimate target for all conversions. It's a type that is so particular it has no instance. Okay, I blew you away, didn't I? I kind of destroyed your minds right now, okay? It's a type that, I'm not kidding, because in Java, right, object, like Java language, is a type that's so general, it encompasses all objects. Bottom is the opposite of object, Lucifer of objects, right? It's a type that is so particular, it doesn't exist. It can't have any instance. What I hear right now is like, whoa, this is deep. I'm 16 and this is deep, right? Okay, awesome. So let's put this stuff to use. So then we say, what if I want to unroll to tuples? So I want to call a function, and instead of just calling the function, I want to put each result of each call of the function into an element of a newly formed tuple. And I say, fine, so let me make tuple of std integral constant, and then I'm going to call it several times. So essentially, it's a transformation that calls a function against the integral constants, and then it's going to call make tuple, not std make tuple. Therefore, I'm going to eliminate anything that is a null field. Consequence, whenever your lambda, by which means you want to create a tuple, wants to ignore something, you return null field. So let me show you. Right? How about the maples? Here, I create a tuple and I want to say I want to insert, in the first case, I want to remove the first element of the tuple. So I create a tuple with 3 fields, and then I'm going to say, if const per I greater than 0, then I'm going to simply return the respective thing. Otherwise, I'm going to return a null field, and as promised, that's going to disappear from the result. So I get to easily remove things from a tuple. All of these are, I'm sure anybody who's worked with tuple knows, incredibly annoying things to write without a bit of support, right? Very annoying. What if I want to insert? So I have a tuple of 2 elements. I want to insert into that tuple somewhere in the middle. So I'm going to say unroll to tuple of 4, right? 4? Did I insert 2? Okay, so I thought I inserted just 1. So in this case, I never return a null field. I'm just going to return good things. Yeah, this is correct. Sorry, I thought it's 2 elements. It's 3 elements initially, and I'm going to insert 1, leading to a total of 4 elements. And essentially, if const per I different from 1, then I'm going to simply return the element from the tuple, and otherwise I'm going to return whatever I want to insert, and I'm good. By the way, you know what this is? Get of I minus I greater than 1. You know what that is? It's a convoluted way of expressing something that is obvious, but this is slideware. I had to fit in the slide. Okay, it really means if it's less than 1, 0. If it's greater than 1, what follows, etc. So it's kind of I'm just using convoluted logic for the sake of brevity. Something that's familiar to anybody who's done any work with CUDA is I have some multi-dimensional arrays and tuples and tensors and whatnot, and I want to initialize them by sizes and ranks. So I'm going to deal with some std array instances, and in this case, I'm going to be able to fill arrays with the appropriate stride and extent. And again, this is classic code that whenever you move to the next dimension, you need to multiply by the extent of the previous dimensions, and that's how it works. So very easy to use Unroll for a variety of purposes. Now there's something quite a bit more interesting because it applies again a bit of reflection. And what I want to implement is each in tuple. And each in tuple takes the tuple, and it also takes a lambda. And what's interesting about this case here, this example, is that the lambda may or may not need the index of the iteration along with the tuple element. So maybe the lambda is like, I want 0, 1, 2, 3, and I want element 0, element 1, element 2, element 3 as two separate arguments, right? Or I don't care about the indexes, I just care about each tuple element. So each in tuple. And again, I'm going to use a bit of introspection, a bit of reflection. Let's say poor person's reflection, because poor man's reflection is not good, right? Poor person's reflection. And to do that, I'm going to call is invocable V. Can I invoke an F with the decal type of I and the decal type of all of this stuff that I'm going to use it subsequently? And if so, I'm going to just do so. Otherwise, I'm going to just pass the current element in the tuple. Now, question for everybody. Is there a simpler way to do that is invocable V thing? C++20 experts, yes, please.
Requires clause.
Very nice. Very nice. All right. What's your name?
Madhav. Madhav.
Manhav.
Madhav.
Madhav.
Yes.
Where are you from?
Sydney.
What school did you go to?
University or high school?
Okay. University of High School. Okay, let's start with primary school, please.
I went to 3 different ones.
Okay. All right. I had the premonition that you are a complex person. So he was right. Requires clause. We can actually use sort of an inline concept here that says requires that if essentially like a compile time try. Could this code compile? And notice there's even a semicolon in there, which is kind of looks awkward, right? It looks like why is this semicolon doing? It's like a good semicolon in a bad neighborhood, but it's got to be there, right? And if that actually works, then I'm going to essentially call the function with 2 arguments. Otherwise, I'm going to call the function with 1 single argument, right? And that actually makes a variety of things easy, such as I want to convert an array to a tuple or vice versa. And it's super simple because all you need to do is, yeah, sure, unroll to tuple of 3, and I'm going to give you a lambda that returns each element in turn of the tuple, and I get the array, right? I get the tuple. So it makes a lot of annoying chores really simple. Finally, last but not least, we got to implement a small vector of which there are a couple of implementations online. For NVIDIA, we had to kind of finagle it a bit. But I'm not saying this is kind of a new artifact. It uses a small vector optimization, right? And essentially, it has the STD vector interface, but for small size, it's going to store the elements right in the vector object, right? And beyond like a few elements that are, you can choose, it's going to use backend of a normal STD vector, right? So actually, it turns out it's very good for performance in a variety of cases. But what I wanted to tell you here is that this was implemented in 2 hours. What took me at Facebook, at Meta, not Facebook, what took me like a week, I've done in 2 hours, right? Because I said, just generate me the whole, I told it what to do. And initially, it didn't want to. So are you serious? Like, there's ... like, do you mean the whole STD vector interface? Because that's a lot of work. I said, yeah, that's why I'm giving it to you. Yeah, it is a lot of work, friend. Yeah. You know what works? If this doesn't get done, the Taliban will have my head, right? And then it's going to be like, sure, I'm going to do it for you. And it did in 2 hours. And this has, if you look at it, it has a couple of interesting tidbits about it. One of which is even the small size. Sometimes you want to unroll, like duplicate the code, but sometimes if the small size is too big, you actually want to loop. So there is a check there, and there's a use of unroll and everything. So it's kind of a cool thing. Anyhow, that entire discussion takes us to partial unrolling, which is a completely different beast, right? We are at partial unrolling now. Partial unrolling is quite different because instead of I want to unroll this code verbatim n times, I want to unroll this code these many times, but modulo a bunch of other times, and you take care of the leftovers. Right, that's partial unrolling, right? Very useful. So making sure that everything kind of stays in check and is efficient and everything is quite a bit harder than it may seem. I should actually mention one important thing. Many people, question to everybody. Why do you think partial unrolling is good? Why do you think it generates good code? Yes, please.
The fetching of the instruction and the comparison of the index.
The comparison knows the index. It doesn't know the index really because it's a dynamic index. It has a static component, but it's not entirely dynamic. So there will be a more fine answer. Vectorization. There are compilers that are going to try to do that, but there's not going to be a vectorization in a GPU because it's already part of vectorization. There is a simple answer. Yes, please.
It avoids the checking the for loop.
It avoids, that's one, so it avoids the overhead of checking the end of the for loop. Although in the presence of prediction, of branch prediction, actually that's going to be a branch that's going to be very well predicted. So yes and no, yeah? There is a simple reason. I'm not going to kind of prolong this cliffhanger too long, right? Too much. It's register allocation. It turns out that if you unroll a piece of code, there's going to be a more contiguous, what they call a basic block without any test for the compiler to look at. And it turns out that the register usage is going to be much better, especially in a GPU, which has a bunch of registers. And register allocation is a big topic in GPU coding. And it turns out that if you have a loop, it's going to mess up the dependencies and everything. But if you have like a bunch of straight line code, then the register allocator is going to do very well. So there are good reasons to do partial unrolling, friends. So let's do it. Take one. As I'm sure you know from my past talks, who has not been in my past talks? All right, 0 hand. Oh, come on. Keep the hand down. Shh. So as you know very well from my past talks, the fastest loop is an infinite loop. Always do an infinite loop if you're on fast code. There's no fast code without an infinite loop, right? So do an infinite loop, and I'm going to check if I have a full multiple of the unrolling size here. And if I do, I just unroll, reusing nicely my previous code. So I'm reusing unroll, right, from what we just discussed. And I'm going to move to the next iteration and so on. So that's going to do, let's say the unrolling factor is 8. We're going to do 8 by 8 by 8 until I get to something less than 8. And when I get to something less than 8, I'm going to do the leftovers. And in this case, I'm going to stop early by means of that Boolean return that we discussed. Remember, we're doing introspection, the return time. If it returns a bool, it's liable to return early, and I'm using it. And it's a beautiful case of reuse because in these 10 lines, I wrote a very nice partial unrolling engine, which is bad. Because there's going to be one test for each leftover element. It turns out if you're in GPU and you have, let's say, 15 elements, iterate by 8, so you do 8, and it turns out if you do 7 more, that's going to essentially double your running time, right? If you do a bunch, if you do 10,000, it turns out, the code is going to be so parallelized that each little thread is going to get a little chunk of the input, and then that tail is going to double its execution time. And if each little thread is going to double its execution time, the whole loop for 1 million elements is going to double its iteration time, its execution time. I'm not kidding. I have coworkers who came, who said this, who said, because why did you have one more element in that matrix? Because now instead of waiting for a day, you wait for 2. I'm exaggerating for dramatic purposes, but actually you are liable to double your iteration time. So very often it's a measurable overhead, right? So this whole by the end thing is kind of a problem. I promised myself to mention some cases in which that is the case. Who knows what FHE is? Fully homomorphic encryption. It's a very trendy thing that computes A plus B in as much time as it would take to do it a billion times. It's extremely slow, but it's encrypted. Essentially, you get to do math on things that you never decrypt. So you can process data that you don't have, even the processor doesn't have access to. So it's kind of a fascinating field. And it turns out that if you want to use it, you got to parallelize your code because otherwise it's incredibly slow. And if you want to parallelize it, you're going to have a bunch of small kernels. So we want to solve this problem. And when you want to unroll something cleverly, bisection comes to mind. Because let's say I'm unrolling 16-way. And if I'm rolling 16-way and I test against 8, if I'm greater than 8, I can do 8 without ever checking, right? Because it's going to be at least 8. I don't want to do are you greater than 16, are you greater than 15, are you greater than, no, are you greater than 8? Oh, if it's greater than 8, do 8 times. Make sense? If I, by means of bisection, I test against 8. If it's greater than 8, I do 8, and then I test against 4. If it's greater than 4, I'm going to do another 4. And in 3 tests, I'm done, right? Which is pretty nice. So in log n test, in the general case, I can actually inline unroll n chunks of code. So instead of 16 tests, I'm going to do 4. Sorry, not 3, 4. So let's code this good stuff. So we're going to define this function unroll leftovers, and we pass the limits of the unrolling to it. And this, I apologize. I know it's late in the day. This is the largest slide. This is the most dense slide. Okay? I don't expect, because it took me like a while to write it, right? So I don't expect it to be very clearly understood. You can, of course, look at it later. Sadly, you can't kind of pause and look at it right now, but sorry, you're not on YouTube. YouTube people, you can't do that. But in essence, what I'm doing is I'm checking for the half of it, and there's an important pattern here, which is I have an and an if, right? I have an if and an else. And on my if and an else here, I say I'm going to unroll the lower part, the higher part or the lower part. So this kind of, if you do any binary search, binary bisection, whatever, you're going to see this pattern. So I'm either dealing with the upper part or the lower part. But what's important is that there's a runtime if. It's not an if const expr. It's a runtime if. And because it's a runtime if, guess what the compiler has to do? It has to generate this stuff and this stuff. Because the compiler doesn't know that a runtime was going to happen, right? So it's going to generate both sides of the branches of the if, which is our problem. Why do you think that's a problem, friends? Code size. Who said code size? Thank you. I'm not going to ask what school you went to because we get into a long story here. But yes, the generated code is going to be humongously large. It turns out it's going to be 128 calls for 16-way unrolling. Because for N16, I'm going to generate 2 basic blocks of length. When I say basic blocks, is like without test. 2 basic blocks of length 8, because if else. And then 4 basic blocks of length 4, and then 8 basic blocks and so on. So I count 128. Now, the compiler, when it sees this nonsense, it's going to be like, this guy's an idiot. What can I do here? And believe me, it does. Because instead of 128 calls to the lambda, I looked at the assembler. My compiler generated 92. I'm not kidding. It kind of figured out some common sub-expression, whatever, and it said, you know what? You asked me for 128. I give you 92. And the code was a bit like, it was 8% smaller than, the ridiculously big, right, whatever. So still not good. how would you address this problem? And this is like, we're getting to the end of this, friends. We're getting to the end. And this, remember I told you at the beginning, this is the best slide? The best slide is coming, friends. And it's going to be awesome. It's going to be awesome. I hope it's not this one. Is this one? It is. This is the best slide, my friends. Okay, what is the difference between this slide and the other is that instead of if else, I have a portion that's common to both branches, and then I have a specific portion. And again, I'm not asking you to say, oh, let me look at that little comma there. I'm not asking you to understand the full code, but if you see this pattern, it means there's reuse in the sense that here I'm having all of my basic blocks of length 8. There's one basic block of length 8. Everything that's go here is going to be less than 8, like 4, 2, or 1, right? Which means I generate the basic block of size 8 exactly once, and then I'm going to generate the basic block of size 4 exactly once, and size 2 exactly once, and then here's my kind of the recursive call. So because of instead of if and else I have common portion and if, I got the function down like to 10x, 10x smaller. It's going to generate only log n calls. I can read on your face that you're not mightily impressed, as I hoped, by this best slide. So, well, be that as it may. However, I think you can appreciate the subtlety of they do look, actually, this looks a bit simpler, but not a lot. I mean, it looks eerily similar to this guy, which generates 10x the code, right? So there's a lesson there. And by the way, just before we get into the summary, just by the way, models can't do this for you. They don't look at the generator assembler yet. I'm not shortchanging them. They don't look at the generator code, they don't do this. But if we give them this function, they're going to be able to look at it and kind of make statements about it. They can analyze it, right? They can make salient assertions about the code, right? But they can't discover it. You got to do it yourself. So to summarize, we got some really nice partial and total unrolling by combining a few simple micro ideas. We use varied expansion to effect unrolling, all that ... comma, or with ampersand and whatnot. Very nice expansion. Fold expressions, they obviate the need for a bunch of template instantiations, very friendly to the compiler. We encapsulate and hide all users to std integer sequence. Please do that in your own code. Don't fight with it directly. Put it in a few library functions and hide it from your view. And we got to use a bit of simple introspection to assess whether the lambda is ready to exit or if it takes 2 arguments or 1 or whatnot. Before we end, I gotta make a few more notes about AI. So as I said in the beginning, stop using chatbots. And when I first said this, there were like a couple of people who were like, yay. And I can only assume those were the Luddites. Right? The people who did not like AI in coding. All right, please don't be that. Don't do that. Coding is going to be changed fundamentally in ways that we have no idea. And by the way, remember the rights I told you in the beginning? Like, how can I use this with my AI tool? How does this help me with AI? And, that kind of stuff. And actually, at this conference here, why do people go to back to basics? Because back to basics it's not going to help you. The agent knows all about back to basics. Why do you go to back to basics? Okay, did nobody in this room? Nobody went to back to basics talk? Yes, please. Why did you go to back?
It keeps changing with every language versions.
It keeps changing, but you can ask your model about it. Right? Yes.
How do you know if the model's right? You have to have the fundamentals.
How do you know whether the model's right? You have to have the fundamentals. So there's 2 aspects to this. Thank you very much. Indeed. So number 1, models nowadays, and probably in the foreseeable future, and by foreseeable I mean within the next couple of weeks, they're going to be only able to amplify whatever you know, but not kind of do the insights for you, like our micro ideas that we discussed here. So mals are going to be able to do a lot of stuff as long as you have a good notion of what to ask, what to tell them to do, how to assess their output, and that kind of stuff, right? So in that case, you have to be able to keep in your mind as much as you can. This actually goes away from what engineering has taught us, because engineering teaches you should know in which book you're going to look up the formula. That's what they teach engineers. But you got to approach things in more like a philosopher. A philosopher wants to keep in their mind the stuff. You want to keep in your mind the stuff. You want to kind of have a good notion of what you're doing at a high level, so then you can have the machine do the details for you, right? So that's one reason why you should go back to basics. Of course, to the extent you're in a position to want to learn those particular things. And there's a second element, which is the human touch. People are going to go to people conferences because they want to see people teaching them stuff. They want to see me sweating, right? You want to see the instructor fumbling on the stage, right? Essentially, there's a need for humans to talk to humans about things, right? And this, I gotta tell you, this year, back to basics, huge enrollment. Not as much as the previous year, because fewer travels from abroad. I don't think they like the country of El Salvador, where they will be deported if there's anything wrong going with their passport, right? So, let me tell you this. Current agents are like an intern on a high of sugar, caffeine, Adderall, and a bit of cocaine, okay? They're always there for you, ready to help you, ready to do stuff if you pay some money. That's fine. But they're always there for you, and they're going to be very good at following you. They're going to be very good with your micro ideas, and the generated code is going to be still inspected by you. You are going to be the judge, right? And giving a good agent context, giving them context is actually a cheap way of imagining you're training them. Because once you tell the agent, here's the unroll function, do std vector with it, they know what to do, right? So in a way, you train them on the job by giving them the primitives that you want them to use. They're going to understand and they're going to use them. Daisy Holman's keynote today was very apropos about that. So good context is a cheap form of training. And with that, we're done. Thank you very much, people. Thank you. Thanks for being here. Awesome. We are just like literally on time. So we have, we could take a couple of questions if you have. Yes, please.
Yes. So for the problem of unrolling, another common solution to this is just to expand the last element out, or the last set out, and have a bunch of essentially null operations out there, so you don't have any branches. Is this something?
Expand the last.
So like if you have like blocks of 18, but you have, or blocks of 8, and you have like a few blocks of 8 and then a 4, you just expand that last 4 by another 4, and then have kind of null operations there, so there's no ifs.
Oh, not like no ops.
Yeah, no ops.
They're still going to feed an instruction cache.
But can you possibly at compile time do something like that, where you expand things out and do something funny with the lambda or something like that? Is that?
Otherwise, it's not a good idea.
You have
What?
to, right.
Try both.
Okay.
This has a compile time. Use that makes perfect sense.
Okay.
And no piece thrown away.
So you got your answer. Thank you very much.
Thank you.
Bartosz. What up?
Yeah, thanks for giving us a few dots to connect, possibly
you.
Module 3. I wanted to ask about one thing, about this null something class that you defined.
Null object, yeah.
Null
the null
object.
field, yeah.
Is there any chance it should better be final? Because maybe I don't final class, final struct, because maybe you would like to prevent someone like deriving from that class that is kind of special.
Right.
Or maybe not.
Yeah. Thank you, Bartosz, for asking. So the question was, how about that null field, which is right now an empty struct? So would you like to, and while we're at it, maybe we think of making it non-copyable, non-movable, et cetera, et cetera. So this is C++. So in a way, you're right, but in another way, it's like a bit too much complication. So yeah, I would agree making it final would prevent some really, really, really bad people from using it the wrong way.
But then it would prevent them from making non-tuplable types of their own, right?
Right.
Because now they can.
Yeah.
This is my very special type. Never put it into a tuple.
Right. And to be honest, null tuple is in my slides, but in the production code, I use monostate. I just reuse monostate. Reuse, baby, right?
Awesome, thanks.
Thank you, Ruslan.
Yeah, hi, Andrei. Actually, great talk, thank you, but I don't have any questions. I have a small correction. So
Okay.
in your if context per, it's not requires clause. I'm going to put my C++ nerd head. It requires expression. Because requires expression returns you like true or false. Requires clause is a constraint that we put on classes and functions, and requires expression actually calculates the expression. That's why we have requires. But my comment doesn't have a practical meaning, so you might not just listen to me.
I appreciate it, but I have a comeback to it. Stay there. I have a comeback. It's a requires expression, but remember it has a semicolon in it. Everybody was supposed to laugh right now. It's like, this is so funny.
Yeah, let's laugh.
Goodness. It has a semicolon, of course, because there's a statement inside, but the whole thing is an expression. Thank you very much. Yes.
So basically on the same slides, the same thing. You have now to write the same thing twice, directly after each other. Are you comfortable with this? So
On the, take me to the slide you talk about.
yeah, which with the requires clause.
Oh, yeah. Okay. I know exactly what you say, and it's annoying me to no end. You are completely right. Where's the requires thing? Yeah. So I know what you're saying. Okay. It's a ways back. Where is it? Yeah, this is it, right?
You have to
So
write
you have you have this code, then you have the same exact code. That's kind of a does it compile, and if it compiles, actually compile it, right? It's a source of endless annoyance to me as well. And it happens in the D language is the same. And actually it slows down compilation because the way the compiler does it is it's gonna try the whole thing and it's going to compile in so-called gagged mode. In gagged mode, the compiler can't emit errors and stuff. It is just gonna silently try to compile it. And if it doesn't, it's going to return and turn the gag back off, and then it's going to continue execution. So it's a very slow and unpleasant way of doing things. And I completely agree, it would be really nice if there would be a shortcut. But I do have a shortcut for you. Put in a macro. How about that, huh?
I also wanted to suggest that.
Thank you.
Could you like use that to create a tuple and call apply on it?
Use that to create a tuple and call apply on it.
Maybe create a tuple in the if context.
All right, so there's a rule. If you are not at the microphone, you're not entitled to speak. The First Amendment only goes this far. Yes, please.
A question that has been bothering me for about 10 years. How does parameter packs compare to template parameter list from modern C++ design?
With what? With template?
Template lists from your book.
With type
Modern
lists from
C++.
my book.
Yeah.
Okay, so first of all, my friend Ata. Okay, so you're setting the stakes pretty high right now. So you're saying it's something I asked myself for the past 10 years. Right? It's like, what's the person of life right now? I'm, who am I? Right? Ivan from Dostoevsky. Okay, so first of all, the type lists and stuff were macros and whatnot. So they had the problem that they were kind of awkward to, difficult to use. There is a need in the standard for a type list type. Everybody uses tuples that they actually don't instantiate, don't use as objects, but they use tuples to store type lists in them. I've seen this many times. People are like, what are the bases of your class? Right? Well, I have like 3 bases. Fine, give them to me. How can you return 3 types to somebody? Use a tuple. Put them in a tuple and give the guy the tuple because you can't return a pack. Right? You can't say alias using type equals like in STL, right? Inside the std vector, using element type equals t, right? And from outside the vector, you can access the type of the element, right? You can't do that with multiple types, right?
STD type sequence.
Sorry?
STD type sequence.
STD type sequence.
Is gonna be up.
Is gonna be up. Okay, so you guys take it, fight it out. So there is a when?
I don't know. It's just a very cool idea.
It just occurred to you, huh? Okay, good. STD type sequence is it. So they compare, there should be a type list in the standard. There isn't, so everybody's using tuple, and I'm a bit bummed, but not too much. I'm more bummed about this stuff, actually, that requires the duplication. Yes, please.
on this slide, why do you use remove reference instead of remove CV ref T?
Because you are smarter than me, my friend. I should have used remove CV ref T, right? So because there's volatile, I'm gonna have trouble, right? I appreciate you. Thank you very much. Last question. Okay, you're gonna leave me hanging right here. All right, we're good. Thank you so very much. Have a good evening. Thank you.